I'm Brent Nelson. I'm a professor for the School of Workforce Development at Conestoga College, and this is a first in a series of videos where we introduce the topic of Industry 4.0. What we're going to talk about in this first video is the origins of Industry 4.0 and put it in context with the first three industrial revolutions. Kind of explain where it came from and a little bit about where it's going. The first industrial revolution, which spans roughly 100 years from 1750 to 1850, was basically powered by steam. Steam engines, developed in the 1770s, meant factories were no longer restricted to operating beside riverbanks and powered by water wheels. Smaller and more powerful steam engines also meant goods could be transported between plants by steam trains. Production output increased roughly 7 times during this period, and the number of people employed in factories doubled. Assembly lines and electrical energy drove the second industrial revolution, enabling mass production of goods. Electric power was first distributed by power lines in the 1880s, and Henry Ford converted his Model T production line to an assembly line in 1913. Programmable logic controllers, or PLCs, were a significant enabler of the third revolution in manufacturing, replacing mechanical relays and cam timers, and later hardwired relay logic systems. PLCs could be reprogrammed quickly and easily, which made manufacturing much more flexible and reliable. The first computers were built in the 1940s and filled a room. The first PLC was produced in a competition for GM Business in 1969. That's after I was born, so not that long ago, really. Let's take a moment to look at this PLC a little closer. It'll help us understand how the latest industrial revolution is different, but evolutionary. PLCs, programmable logic controllers, allow a machine to monitor its environment through a series of inputs, which could include temperature, pressure, safety switches, and that sort of thing. When the PLC is programmed to make decisions based on those outputs, it then acts on the status of the inputs and controls some number of outputs, machine controls, feeds, speeds, pressures, motion, run, stop, that sort of thing. So the PLC makes the machine aware of its environment and tells it how to respond to that environment. In part, this replaces, or at least supports, the human operator. Now, a really simple model of Industry 4.0 might look like this. Where before even the most sophisticated machine worked independently of other machines, Industry 4.0 attempts to connect all of these smart devices together through the cloud or some other means. Maybe a little more accurate would be to replace some PLCs with other kinds of smart devices, so traffic signals and vehicles, buses, taxis, that sort of thing, all kinds of different vision systems and independent sensor arrays, satellite for communications, imaging, what have you, and all the way down to the personal devices, things like smart watches and smartphones. So this is, to me, a nice illustration that shows a bit of a bridge between Industry 3.0, or the third industrial revolution, where machines were controlled through a programmable device, a PLC, and Industry 4.0, which is the idea of connecting all of these sorts of smart devices together and allowing them to communicate and share information. So now we have this Internet of Things, meaning more and more information shared as inputs and outputs in an ever-expanding global system. A decision in a plant in China, for example, can now be made based on a piece of information initiated wherever you live. Imagine your running shoes, detecting that they're losing tread and initiating an order for a replacement pair in your favorite color, all by themselves. It might sound far-fetched, but when I was last in an office, I had a smart printer, and it knew when the toner cartridge was running low and the supplies were running low. It knew what vendors were approved. It would initiate an order for new supplies. The vendor would then receive the order, dispatch a technician to my office, and replace my supplies or do maintenance on my printer. It's been doing that for the last 4 or 5 years. It's one of the major companies that produces PLCs and has from the beginning is Siemens. They put out this video that I think is a good introduction to Industry 4.0 and talks about how they see Industry 4.0 evolving, knowing that they've been a significant part of the third industrial revolution and will continue to be a significant part of Industry 4.0.
A vision of tomorrow's manufacturing. Products finding their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective, highly flexible, individualized and resource-friendly mass production. That is the vision for the fourth industrial revolution. A look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first Simatic. Production became increasingly based on computer-assisted controls. The fourth industrial revolution is still a vision. Experts believe that it will only become a reality within the next 20 years.
So I want to point out, this is important for you as students in process quality engineering. We are in the fourth industrial revolution, but still in its infancy. So I'll talk in a minute. It was initiated around 2010. This video is in 2013. So that's still only 7 years ago. And they're saying at this point, it's still a vision. It's not a reality yet. And over the course of the 7 years, things have evolved, but there's still a lot to do.
In intelligent factories, everything is interconnected wirelessly. At the German Research Center for Artificial Intelligence in Kaiserslautern, this future can already be experienced right now. Research is underway here into exactly what the industrial production of tomorrow will be like.
Fabriken werden zukünftig aus Bausteinen bestehen, aus smarten oder intelligenten Bausteinen, wie man es nennen mag. Vergleichen wir das vielleicht mal so ein bisschen mit einer Lego-Steinwelt. Das heißt, wir haben standardisierte Bausteine, die wir hoffentlich relativ einfach zusammenstecken und zusammensetzen können. Jeder dieser Bausteine hat bestimmte Funktionalitäten und wir können sie zukünftig in einem solchen fabrikinternen Internet dann kombinieren.
A bottling plant for liquids, set up together with Siemens, is used to demonstrate the most important components of the intelligent factory of the future. Each bottle contains an RFID chip storing a precise description of how it has to be processed. Which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as desired. Factories with networked machines and products are already in existence today. In the future, however, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines, and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate with each other and also control each other cooperatively.
Wenn Sie sich das Thema Industrie 4.0 angucken, dann basiert sie ja auf der Logik dieser Cyber-Physical Systems. Das heißt, Sie haben autokrate selbst arbeitende Systeme, die sich optimieren und sich gegenseitig austauschen und dadurch letzten Endes Produktion optimieren.
So one of the key things that I want to point out in this video from Siemens is it showed how the product itself is controlling the process. So this is a very significant departure from the standard manufacturing cycle where an operator controls the process and the operator makes decisions on how to run the process. And so this new stage where the product does the command structure or is part of the command structure means that there's a lot of customization that can be done. So here they've just taken a very, very simple example of bottles, but imagine an automobile coming through. The customer has decided a certain color and a certain configuration of the stereo and the air conditioning and what have you, all these different options. And so that can be codified on the chassis or the body or different parts in the order. And as it goes through, the chassis then commands the integration of sunroofs and the integration of the proper radio and the proper tires and the proper coloring system. It controls the paint flow into the sprayers and so on. So you don't need the operators making these sorts of decisions. And of course, from a quality perspective, which we're interested in process quality engineering, that leads to a great degree of flexibility with theoretically lower risk. Less human interaction, less human intervention, less human decision making, and therefore less human error. All right, so there's Industry 4.0 in the context of the first three industrial revolutions. So we now have a sense of what Industry 4.0 is and how it fits into these three revolutions. So this new partnership between man, machine, and product, which Siemens identifies and is generally known as cyber-physical systems, as a major concept in Industry 4.0. Another key enabler of this new revolution is artificial intelligence. Because you have this massive amount of information now flowing across the internet and through cloud, interconnecting different devices, which are then expected to make decisions on those, it goes beyond the capacity of human operators and human decision makers. So the need for and the opportunity for artificial intelligence comes into play now that can process all this information and make smart decisions. One of the important things I think it's useful to recognize as a student is what started this Industry 4.0. So unlike the first three industrial revolutions, which were really more identified by looking back in history and seeing different landmarks of technologies evolve, Industry 4.0 was actually planned as a forward-looking strategy. So Industrie 4.0, and I apologize for my poor German, was actually conceived by the German government as one of 10 future projects initiated in July 2010. It's part of its high-tech strategy 2020. So at the time, it was actually a 10-year goal to implement some of the concepts that are part of this. But as you saw with Siemens, who is already a very sophisticated player in this, 3 years into the exercise, they said, you know what, this is a 20-year exercise. So there's lots to be done yet. Companies are just now starting to realize the benefits and the gains and just now starting to implement some of these technologies that we're talking about. So at the time, it was a forward-looking strategy out of the German government in partnership with different research, commercial, and government organizations, aims to drive digital manufacturing forward and the idea of increasing digitization, interconnection of products, value stream, and business models. I'll talk about that in a moment. Germany was already, or has always been known as a center for innovation, but they saw this as, or they saw the need, because of a lot of competition, international competition, to drive technology forward and sort of get organized with a vision, right? So reliable future, applied scientific research, strong pace of innovation in industry and services. So this is another important point. This is not just manufacturing. This now encompasses way more than just manufacturing plants. This is all types of industry, all manner of production, and all manner of services. Okay, and another key piece of the vision here is this goes way beyond just manufacturing plants and organizing processes and having product decide what label to put on it. So there's kind of phases through this. The initial phase is just connecting devices and having devices and things talk to each other through this Internet of Things. But another major visionary step here is this idea of process optimization. Because you have the machines becoming self-aware, then that should introduce or include the quality element of the process. And so the process then can now react to the quality, positive or negatively, and improve and optimize the process. It can also change the whole process flow. So if there's a sort of a more efficient routing or a more efficient, more appropriate selection of equipment, or more appropriate selection of supplier, then this new framework allows for that. And there's the potential for entirely new business models. Ultimate flexibility, where you can have a plant that's capable of producing any number of products, and it just reacts to market demand and turns on and turns off supply chains and processes and material supplies and so on, only to manufacture what consumers need. So entirely new business models could start up as a result of this concept. Industry 4.0 is now global. It's gone way beyond the German industry. It's being taken up all around the world. Here's an example, even where I am in Waterloo, which is a strong research and development hub. There's a great deal of research and work being done to support the concepts of Industry 4.0 and to further develop the technologies. Here's one example, MyoVision, a Waterloo company that focuses on the concept of smart cities. So contributes to analyzing vehicle traffic, bottlenecks, backlogs at intersections and the like, looking at where pedestrians are moving, how pedestrians are moving, whether pedestrians are following proper signals or if they're crossing against lights or jaywalking, what have you, whether drivers are complying with traffic signals, are they following traffic circles properly. Real-time detection for pedestrians so that different warning signs can be set up, or embedded roadway displays can show that there's hazards or something going on, redirect traffic, what have you, and introduce the idea of cyclists. There's all kinds of recognition of more and more alternate vehicles with e-bikes and powered scooters and the like. Right? So the whole vehicular system is becoming more complex. So this company is focused on the different technologies and data analysis, visualization, and command structure that's involved with this idea of smart cities. And two, the Conestoga College, different universities and colleges, it only makes sense that they are also embracing Industry 4.0, incorporating them into their own research, their own coursework. Just as I am with this particular course, it's important for people to understand, it's important for students to understand Industry 4.0, to recognize what it means, what the vision is, some of the technologies that are involved, and for students, the opportunities. So in terms of those opportunities, I very simply have kind of defined sort of four broad categories. Industry 4.0 relies on this notion of smart technology. So to me, that's four major elements. The materials themselves, so the steels, the rubbers, the fabrics, the raw materials that go into the production systems, so that the plant can recognize what it needs, where they are, what the quality is. So all of that sort of incoming inspection should be done through an automated process. Smart machines, obviously. Smart factories, the whole collection, the interconnection of the machines, the communication of systems, the line balancing, the flow control, all the kinds of things that you learn in your lean programs. And then finally, smart products. So producing parts that are themselves smart. A company that I worked for produced bearings, Scheffler, and put a lot of effort into creating smart bearings. So the bearing itself, located in the middle of a machine center, for example, could detect increased friction, increased loads, which predicts some emerging wear pattern, and then it could trigger a preventative maintenance cycle and prevent any kind of downtime on the equipment that's using that particular bearing. But my message to you as a student in studying process quality engineering is that along with these opportunities becomes the challenge, where you need to understand those different technologies and to be willing to learn a little bit of programming, data analysis, data visualization, do some independent study on artificial intelligence. So basically get yourself tuned in and smart enough to be able to work with this. But if you can rise to that challenge, I think there's a world of opportunity. So I've just provided here a very simple example of, to me, a way that any student can, at an entry level, just explore this idea of the Internet of Things, something called the Arduino. It's an open architecture product, so there's a great deal of support, forums, videos, tutorials, and so on. It's fairly affordable. You could buy something like this Arduino Uno for $14 or so Canadian currently, and add to it inexpensive Bluetooth or Wi-Fi modules that allow the Arduino to connect to your internet or to connect to other devices and start communicating with other sensor packages or other Arduinos or other kits or other anything. And then things like this multi-sensor kit that you could purchase that pick up temperature, barometer, or tilt, or position, or movement, or heat, or sound levels, or light levels, what have you, to make your system very aware of its surroundings. And if you incorporate this with 3D printing, where you can build your own cases and levers and physical devices that help these sensors function properly, then you can build very remarkable systems at home with a modest investment. All right, we're going to talk about the technologies in the next video, but I'll just introduce them here quickly. Things like the cloud computing, obviously, with the interconnection of devices, the Internet of Things that we've said is a fundamental part of Industry 4.0, big data analysis and visualization, cybersecurity that comes along with that to prevent exposure of the data, augmented reality, where you're starting to use augmented reality or virtual reality glasses or environments to do training or manipulation of systems, additive manufacturing or 3D printing, different kinds of simulation systems, autonomous robots, and so on. So that's my introduction to Industry 4.0. It's not a comprehensive summary of it. Industry 4.0 is a fascinating and multi-pronged topic, but I wanted to give you a taste of what it is and start you on your way to researching and further understanding this really, really cool topic, and more than just a topic, but the time that we're currently living in and what's driving so many things in engineering and quality right now. So thank you very much for listening, and I'll see you in a future video.